Hey everyone, Miss Pariseau here to talk to you about multi-step equations. In the previous video, we had talked about two-step equations, which required two steps. Now these ones are going to have two or more steps in them. And we're going to see when there's variables on both sides because they're pretty much all the same steps. Okay, so just like in the two-step equations, I have kind of like a checklist for you. And you can even abbreviate it if you wanted to, and I'll show you how I do that down the side of a problem. So again, our goal is to always isolate the variable, aka get the variable all alone. So we're going to do that by simplifying everything. I want you to think about it like, imagine you're getting ready to go to school, right? Let's say your parents are taking you this morning. You wouldn't go and put just your pencil in the car, then come back and get your book to put in the car, and then go back and get your backpack to put in the car, right? You would pack everything up into your backpack and then go to the car. So it's the same idea here, is that we want to condense everything. We want to simplify everything on the left and the right-hand side before we start doing any inverse operations. So the first thing we want to look for is, do we have to get rid of any parentheses by using the distributive property? So just kind of yes or no. If yes, go ahead and do that. If no, move to the next step. The next step, it's kind of these two steps kind of go together. We want to simplify the right and the left-hand side of the equations by combining like terms. So that's kind of that idea of that backpack. Pack your bag before we start traveling, okay? So combine all your variable terms, combine all your constants, all of that, if you can do that. If not, you just keep on moving. Then we need to see, are our variables all together? We want to keep all of the things like together. All our variables like to stay and hang out with one another. All our constants want to be on one side of the equation. Okay, sorry about that, Bill. And then once we kind of have all that arranged and simplified, we can go ahead and use our inverse operations to solve the equation. Remember, using PEMDAS backwards. And then we can check, we can always go back and check using our original equation. So let's take a look at how to work through that. Okay, so we're going to go ahead and start with number one here. And first rule, I like to kind of just create a boundary line because I don't want anybody sneaking over. Okay, so if I'm using my checklist, right, so the way I think of it is as look for the distributive property, combine like terms, right, collect your variables, right, and then we're going to go ahead and solve. So my checklist is DCCS, distribute, combine, collect, solve. So you can even use that as a little acronym down the side of your paper. So I see parentheses and there's multiplying happening, so I'm going to go ahead and distribute. And I get 3x plus 24 equals negative 6. So I distributed on that side. Again, I'm not moving anything yet. Do I have any like terms that I can combine on the left? No, I don't. I don't have any like terms on the right to combine. When it's combining like terms, it does not mean you're crossing the equal sign just yet. There's no variables on the other side. They're already on the left-hand side, so that is fine. And so now we can go ahead and solve by using inverse operations. So I'm going to subtract 24. I get 3x equals negative 30. I'm going to divide both sides by 3. And I'm going to get x equals negative 10. If I wanted to, I could plug that back in up top. Negative 10 plus 8 is negative 2. And negative 2 times 3 does give me a negative 6. So I know that I got that one correct. Okay. I'm going to work my way down these three examples and then leave these ones over here for you to try and then check back in with me. Okay. All right, so let's go on to number 3. Again, you're always welcome to pause the video and see if you can do it on your own before going through with me. All right, so going through my steps again, distribute, combine, collect, solve. I do see that I have parentheses, so I want to go ahead and take care of that. So I get 3k plus 15 plus 2k. Remember, this is not in parentheses, so it doesn't get distributed. Don't forget about that guy. All right, so I distributed. All right, well now, so I did that step. Combine like terms. So if I'm looking at my like terms, I have 3k and 2k that I can combine there. So I'm going to get 5k plus 15 equals negative 23. So I combine my like terms. I don't have to collect any variables because the variable's already on one side. There's nothing over here to bring over. So we're good with that. I can go ahead and start solving. Subtract 15 from both sides. Cancels out because it's a zero pair. 5k equals negative 38. Then I'm going to go ahead and divide by 5. And we have here k equals, now you can leave it as an improper fraction. It all depends on what the directions tell you. If there aren't any directions, if it's a fraction, just make sure it's simplified. This is simplified. Some people say it's not because it's improper. Simplified and improper are two different things. Okay, so it is simplified, but maybe we want to change it to a mixed number. 5 goes into 38. That's a negative, so 7 times. That's 35, so that's a remainder of 3. Or maybe you used your calculator and you got negative 7.6. So these are all acceptable answers for that. And I would make sure that you know how to represent that number in all 3 different ways. Okay? All right, let's go to number 5. So notice how number 5 is different from 1 and 3. This is going to be stuff that's coming on our next assessment, but I'm going to go ahead and show it to you because it's really, they all go together, okay? So we're going to go ahead and put down our railroad tracks, and we're going to DCCS. Do I have any distributive property anywhere? There's no parentheses, so I don't need to do that step. Can I combine like terms on the left? Yes, I can. 4m minus 7m is negative 3m plus 10. Can I combine any like terms over here? No, I cannot. You always want to check both sides. Okay, so I combine my like terms. Now the next C, remember, means collect. Again, I like to think of it as we've got our variable terms. These are the guys with the last names. I call the variables their last names. And then we have our divas, the constants that have no last name, right? All of our divas want to be on one side. Our constants want to be on one side. And all of our regular Joe Schmoes, our variable terms, want to be on the left. Well, it doesn't matter left or right, but they all want to be on the same side. Okay, so I'm going to go ahead and I want you to get in the habit of doing this. And I'm going to emphasize this, and you're going to see and understand why later. Move variables first. Okay, move those variables first. Do not move. It's okay if you move the 10 first. It will work out okay, but there's a reason moving forward that I'm going to say move the variables first. Collect those variables first. So I'm always going to take the smaller one and bring it to the larger one. You might say I'm always going to bring my variable to the left. It's really up to you. So I'm going to move this small m. Again, I'm saying absolute value. So it's really a positive 1m. So I'm going to minus 1m from both sides. Oh, I didn't use my different color. That's okay. Negative 3 and negative 1 is negative 4m plus 10 equals, well, those guys canceled out, 2. Go back to my opposite color. And now that I've collected my variables, I only have one variable term. Notice I don't have 2 m's floating around. I have just the one term with an m. Now I can start solving. And those guys cancel out, and I get negative 4m equals negative 8. Careful, that's 2 minus 10, which is negative 8. Divide by negative 4. Gotta love all my sound effects over here. We get m equals a positive 2. M equals, and if you want to put the positive sign to say, yep, I checked my signs, go for it. You do not need to. But that's just me emphasizing it's a positive 2, not a negative 2. Or if I accidentally wrote a negative sign and I'm trying to change it, instead of erasing it, I'm just going to turn it into a plus sign. Okay? So what I'd like you to do is go ahead and pause the video. And when you're done, you're going to come back and check to see how you did with these problems 2, 4, and 6. All right. See you soon. Okay, let's see how you did. All right. you should have gotten x equals 11. The only thing you had to do here first was combine like terms, and then you would have a two-step equation and then solve. That one's pretty straightforward. And number 4, you should have gotten b equals 6. So there was no distributing, no combining like terms on the same side. We did have to collect our variables. So I moved the 19 because it was a smaller number over here. It's just my way of kind of like avoiding a negative. Okay, you could have moved the 24 over there. That's fine. You just would have had a negative answer on this side, but we still end up getting the same final answer. So your steps might just look a little bit different. Okay, and then for number 6, here we had to do the distributive property, and then we also had a variable on both sides. So I moved the smaller number to the larger number side, and then I ended up with a a one-step equation and got x equals 53. All right, let me know if you have any clarifying questions, and I will talk to you later.